4.3 and 4.4 are going to be teaching us how to write the equation of a line in different forms and how to use those particular forms to graph the lines as well. The very first form we're going to talk about today is called point-slope form. And spoilers, point-slope form, all you need to write an equation in point-slope form is a point and a slope. Hence the name point-slope form. We will also talk about other forms in the next section. In 4.4, we'll talk about slope-intercept form, and we'll go more in depth about standard form as well. But I'm going to tell you that point-slope form is the root of all forms. Every other form comes from point-slope form, and there's going to be a huge focus in 4.4 about how the very first thing you're going to do is write your equation in point-slope form and then transition it into a different form as needed. So this is very foundational. In AP Calc BC, I don't even have them write it in any form besides point-slope form. So really, please pay attention, focus up. This is going to be a great lesson that's going to help you write an equation in point-slope form. So right here we have the equation for slope. M equals y2 minus y1 over x2 minus x1 from 4.2. Let's manipulate this equation like we did in Unit 1. Let's multiply everything on both sides by x2 minus x1 to sort of isolate our y's. That would give us y2 minus y1 equals our slope m times x2 minus x1. And this actually is point-slope form. But what we do in point-slope form is we just drop the 2's. The 2's go away because in every equation of a line, we should always have an x and a y in our equation, because we should be able to plug in x values to find y values. That means in every equation that we're writing in point-slope form, we need to plug in a y1 value, a slope, and an x1 value. The x and the y that don't have subscripts will just stay there. So our final answer should look something like y minus 5 equals 2 times x plus 4. There's an example of an equation in point-slope form. So how do we do this? How do we write an equation in point-slope form? Well, in order to do this, we need two things. We need a point and we need a slope. What you will do is you will plug the point in for x1, y1. So that will go in the x1, y1 part. You will plug the slope into your m into this equation, and then you will stop. Fight the urge to distribute. You're not going to distribute. You're going to just plug those three things in and stop. Just like with 4.2, watch out for your double negative situations. If you have something like y minus negative 5, you should rewrite that as y plus 5. So just be aware you may have a double negative situation happening. Make sure you turn that into a plus. Other than that, you're plugging those three parts in and leaving it. So on number 1, I have my slope is 1/6. That's going to get plugged in for m. I have my y1 is 1, and I have my x1 is 5. So y minus, and I'm going to just color coordinate this, y1 is going to equal our slope times x minus x1. Now remember, the x and the y that don't have subscripts, you're not going to plug anything in for those two parts. You're going to leave it exactly as is. So let's plug in what we know. We know that y1 is 5. So y minus 5 equals, we know that our slope is 1/6, parentheses, x minus, we know that our x1 is 1. This is it. Right here is where you stop. This is the equation of a line that has a slope of 1/6 and that passes through the point 5, 1 in point-slope form. We will talk about in the next unit how you can transition this into slope-intercept form and standard form, but for right now, this is as far as we need to go. So looking at number 2, I have my m, I have my y1, I have my x1, and we're just going to plug everything in. So y minus, my y1 is 3, equals my slope, -4, times x minus my x1, which in this case happens to be 0. You're more than welcome to leave it like this. You also could rewrite this as just -4x, since x minus 0 is just x. Why don't you go ahead and pause the video and work through number 3 on your own. Okay, y minus, our y1 is -4. So notice we have a double negative situation going on here, so that's going to become y plus 4. Our slope is positive 1, which we don't have to write, and our x value is negative 1. So again, we're going to have a double negative situation, so that should become x plus 1. You can write a 1 in front of the parentheses if you would like to. You do not have to. Number 4 looks different. In order to write the equation of a line and point slope form, we need a point and a slope. And on number 4, we do not have those two things. We do have two things. We have 2 points, but we don't have the slope. But just like we learned in 4.2, we can find the slope of a line if we are given 2 points. And we can do that using our slope formula, which is right up here. So let's go ahead and find the slope first. y2 is 6, y1 is 3, x2 is 5, x1 is 2. That's going to give us 3 over 3. That's going to give us a slope of 1. Now you have 2 points here, which means you have 2 possible answers. Let's look at the first point. Y minus 3 equals our slope, which is 1, times x minus the x value of that point, which is 2. There's one completely correct answer. You would not have to do anything else. Another way you could write this is using the other point. Y minus 6 equals 1 times x minus 2. Not x minus 2, x minus 5. Now you should be thinking, how are those the same? They sure don't look the same. I have 2 different answers and they look very different. But let me prove to you that they are in fact the same. Y minus 3 equals x minus 2. If I went back to unit 1 and I solved for y, this would give me y equals x plus 1. Let's look at the other equation. Y minus 6 equals x minus 5. If I added 6 to both sides, I would get the exact same equation, which is actually what we're going to talk about next class. That's slope-intercept form. But no, either of these 2 equations is an accurate point-slope form equation. Now let's talk about how do we use point-slope form to graph. In order to graph using point-slope form, we have 2 pieces of information, and they're given away in the title of this type of equation of line. We have a point and we have a slope. In order to graph a line, as we talked about in 4.1, we just need 2 points. So what we can do is look at the equation of point-slope form. We can identify the slope. That's going to tell us our rise over our run. So that's going to tell us how we can move from one point to the next. The other thing we need is a starting point. So any point on the line, we know 1 for sure is the opposite of what we see here and the opposite of what we see here. Because remember, we originally plug in the point x1, y1, but in the formula, we're subtracting. So what I mean by that is, if you look back, the point 5,1 was in number 1, but how that looked in the equation was -5 and -1. So when we're looking at the equation, remember you're going to take the opposite x value of the number you see with x and the opposite y value of the number you see with y. So identify and plot the point, and then use your rise over run to move from one point to the next. Don't forget to connect the dots and make sure you have arrows on the ends of your line. So on number 5, our slope is 2. I'm going to write that as 2 over 1 because 2 tells me I'm going to move up 2 and I'm going to move to the right 1. Every time I move up 2, right 1, up 2, right 1. You're always going to be moving to the right unless you're running out of space. Then you can do the opposite of both of those things, but you're always going to be moving to the right. The ordered pair I see -3, that means x is +3. I see -1, that means y is +1. So I'm going to plot the point 3, 1, and I'm going to use my slope, up 2, right 1, up 2, right 1. I'm going to use the rest of this graph because it's very difficult to draw straight lines on this iPad. I'm going to go down 2, left 1, just so that I can continue the pattern all the way off the graph. And I'm going to connect and make sure I have arrows on the ends. When you're doing this in Go Formative, use the straight line tool to connect and then make sure you draw arrows on the ends. If you're doing this on the paper, make sure you're using a straight edge to connect the dots. Number 6, the slope is just this number right in front of parentheses. The slope is 3 over 4. That means that I'm going to move up 3 and right 4. The ordered pair, I see +2 with x. That means x is -2. I see -1 with y. That means that y is +1. So I'm going to plot the point -2, +1. From that point, I'm going to go up 3 into the right 4. I'm already out of space there. So I'm going to go down 3 into the left 4. That doesn't even really fit. And I'm going to connect the dots, and I'm going to make sure I have arrows on the ends. In fact, I'm going to add arrows to the ends of number 8. Why don't you pause the video, identify the slope in your point. Remember, if your slope is negative, instead of moving up and right, you're going to move down and right. So pause the video, identify the slope in the point, and then connect the dots and unpause the video and see how you did. So the slope, the number in front of parentheses, is -1. That means I'm going to go down 1 and right 1. From the starting point, the opposite of the number with x is +2. The opposite of the number with y is -2. So we have the point 2, -2. We're going to go down 1, right 1, down 1, right 1, down 1, right 1. And I'm going to keep the pattern going all the way off to the left since I already have trouble enough graphing these. Straight line on this iPad. And there is my graph. The very last problem is going to tie many of these sections together. We're going to write the equation of a line twice. We're going to write it using the left point and the right point. So in order to write the equation of a line in point slope form, I need a point and a slope. So let's use this point. This point is 0, -1. So I have y minus -1 equals the slope, which we'll come back to, times x minus 0. This is going to become y plus 1. This is just going to become x. Let's go ahead and look at the graph and let's find the slope. Well, the slope is just the rise over the run. We're going up 1 and we're going over 2. Make sure you pay attention to that scale factor there. So that means my slope, rise 1, run 2, is going to be 1/2. So here's one equation. Now we could do the exact same thing with the other point on the graph, which is 2, 0. And notice these are special points. What kind of points are these? Think back to 4.1. These are intercepts. So here we wrote it with the y-intercept. Now we're going to write it with the x-intercept. Y minus 0 equals the slope we found, 1/2 times x minus 2. You could drop the y minus 0 part since y minus 0 is still just y, but either of these would be acceptable. So let's recap these notes. Point slope form is y minus y1 times m, or equals m times the quantity x minus x1. That is point slope form. In order to write an equation in point slope form, you need the point and the slope. You're going to plug the slope in for m, you're going to plug the point in for x1, y1, and you are not going to distribute. If you are graphing using point slope form, you're going to start by identifying the slope and the point from your equation. Don't forget, you're going to take the opposite of the x and the y's that you see. You're going to plot the point and you're going to move up and right or down and right based on your slope to graph the next point. Remember, when you connect, to draw arrows on the ends. Looking forward to supporting you on this in class. Thanks for listening.